friends, welcome back to our channel Concept with Clarity 1. In this lecture, we will try to see the number system conversions. Like we all know, there is a need for converting one number from one number system to the other number system. Like if I give an example, I am taking a digital calculator where I wanted to perform an addition operation, let us say 4 plus 5. Okay, I give the inputs in the form of decimal, but my hardware understands only binary. Okay, so zeros and ones. That is why there is a need to convert from decimal number system to binary. Once the processing is completed, again that binary number system, that binary number has to be converted from binary to the decimal. Okay, again you are converting from one number system to the other number system. Okay, so apart from this, there are multiple applications where there is a need of converting from one number system to the other number system. So we will see the number system conversions in this particular video. Okay, so before starting that, first let us see how the numbers are represented in binary number system and octal and hexadecimal number system. See here, in binary 0 is represented by 0, 1 is 1, so there is no change here. There is no change here. Directly you can have these numbers only. Whereas coming to octal number system, your octal numbers are from 0, 1, 2, 3, 4, 5, 6, 7, like we have seen in the last class. Okay, so here 0 is represented by 3 bits. Okay, 0 is represented by 0, 0, 0, 1 is represented by 0, 0, 1, 2 is represented by 0, 1, 0, 3 is 0, 1, 1, 4 is 1, 0, 0, 1, 0, 1, 1, 1, 0 and 111. This is how you represent your 0 to 7 numbers in the form of binary in 3 bits. Okay, so whereas coming to hexadecimal number system, each and every bit, okay, each and every number will be stored in the form of 4 bits. It will be represented in the form of 4 bits in the hexadecimal number system. In octal, 0 was represented by 0, 0, 0, but in hexa, 0 will be represented by 4 bits, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 3 is 0, 0, 1, 1, 4 is 0, 1, 0, 0, 5 is 0, 1, 0, 1, 6, 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 0, 1, A is 1, 0, 1, 0, B is 1, 0, 1, 1, 1, 1, 0, 1, 1, 0 and 1, 1, 1, 1. This is what we represent the numbers in the octal and hexa. By using these things, we will try to convert from one number system to the other number system. Okay, we'll start with the basic one. First of all, we know decimal number system, right? We use decimal numbers. Okay, now let us try to convert a decimal number. Let us say I will convert 74 base 10. Base 10 means it's a decimal number. You convert it into binary. Okay, you convert it into binary, that is in the form of zeros and ones, right? So 74, what you will do is simply divide it by 2. Okay, you are converting to the base 2. Okay, so it is 3s are 37s are 2 37s are 74, remainder is 0. 2 1s are 6s are 2 16s are 32, 2 17s are 34, 2 18s are 36, the remainder is 1. 2 9s are 18, remainder is 0. 2 4s are 8, remainder is 1. 2 2s are 0. 2 1s are 2, it is 0. So how you write the answer is, you just write in the reverse order. You write in the reverse order, that is 1 0 0 1 0 1 0. Okay, this is in the representation of binary. Okay, so any number, if you wanted to convert from decimal to binary, then what you have to do is you need to divide it by 2. Okay, similarly, if I wanted to convert a decimal number, let us say 124, let us say I need to convert this into octal, that is base 8. Okay, so what you will do is you need to divide 124 by 8. Okay, this is, I will write this one, decimal to binary. Okay, this is decimal to octal, decimal number system to octal number system. Okay, so what you will do, you need to divide it by 8. Okay, so 8 1s are 8, and if 8 5s are 40, so 4 is the remainder. So 8 1s are 8, 7 is the remainder. So the answer here will be, so 124 base 10 is equals to 174 base 8. Okay, so kindly note that all the numbers which you are having in the octal number system will be ranging from 0 to 7 only. Okay, that is how you convert from decimal to octal, right? Now again, if I take another number, let us say decimal number system to hexadecimal number system. Okay, now I guess you will be getting an answer. Simply what you will do, you will divide it by 16. Okay, for suppose if I take the same number 124, the same number, if I wanted to represent it in base 16. Okay, so what you will do, is you will simply divide it by 16. Okay, right? So you can see here 16 sevens are 112, 16 sevens are 112, and the remainder is 12. 12 is represented by, like I have shown you, 12 is nothing but 10, 11, 12. 12 is C, correct? 12 is C. So 7C is the answer. 124 base 10 is equals to 7C base 16. Okay, 7C base 16. So this is how you convert decimal number system to binary and octal and hexadecimal number system. Okay, now if you convert, like now we have converted the decimal number system to binary and octal and hexa. Now if you convert it back, okay, like binary number system to decimal number system. Okay, we will try to convert it back. Okay, so I will show you. You see here. So for suppose I am having 10111010. Okay, base 2. I need to convert it into base 10. Okay, what you will do is you write the number 1011010, and here you will be multiplying with the 2 powers. Okay, the weight by 2 powers. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5 and 2 power 6, right? So my answer will be, you multiply 2 power 6 into 1 plus 2 power 5 into 1 plus, sorry, this is 0, plus 2 power 4 into 1 plus 2 power 3 into 1 plus 2 square into 0 plus 2 power 1 into 1 plus 2 power 0 into 0. Okay, you can directly discard the zeros once. So this will be 2 power 6 is 64 plus 2 power 5 is 0, 2 power 4 is 16, 2 power 3 is 8 plus this is 0 plus 2, correct? So 64, this is 88, 90. So this is nothing but 90 base 10, correct? So this is how you convert an binary number system to decimal number system. Similarly, if I wanted to convert an octal number system to decimal number system. Okay, for suppose let us say if I have a number called as 104 base 8, I need to convert it to base 10. Okay, so what you will do is first you write 108 here, right? And then what you will do, 108, now you multiply with respect to 8 powers. Okay, so 8 power 0, 8 power 1, 8 square. Okay, so this is 8 square into 1 plus 8 power 1 into 0 plus 8 power 0 into 8. Okay, so that is equals to 64, this is 0 and this is 8, that is equals to 72 base 10, right? So this is how you convert octal number system to decimal number system. Now if I wanted to convert the same number 104 base 16 to base 10, okay, so this is hexadecimal number, this is decimal number. So what you will do, again you write 104 here, you multiply with respect to 16, 16 power 0, 16 power 1, 16 square. So this is 16 square into 1 plus 16 power 1 into 0 plus 16 power 0 into 4. Okay, so you can see what is the answer for 16. 16s are 16 square, it is 256. 256 plus 4, that is equals to 260 in base 10. Okay, so this is how you convert an hexadecimal number to decimal. Okay, so what else is left now? If you see, we have converted binary, octal, decimal, hexadecimal. Okay, so we have converted from binary to decimal and decimal to binary. Okay, octal to decimal and decimal to octal. We have also converted decimal to hexa and hexa to decimal, right? So now we will try to convert binary to octal and binary to hexadecimal. Okay, binary to octal and binary to hexa. So you see here, for suppose if I have 10110 base 2, if I wanted to convert it into octal, what you have to do is you write your number 10110 and you divide it into 3 bits. Okay, so this is 3 bits from the LSB. So this is 3 bits, 0 1 3 bits, and here I will write as 0. Okay, like I already told you, 010 is 2, 110 is 6, and this is 5. So the answer will be 265 base 8. You divide it into 3 bits. Similarly, if I wanted to convert binary, that is base 2 to base 16, then what you will do, you need to divide it by 4 bits. 1011011010. Okay, so if this is my number, then what I will do, I will divide it in the 4 bits. 1 2 3 4 1 2 3 4. I will write 3 zeros here. Okay, 3 0, this is 1, 0110 is 6, 1010 is A. Therefore my question was 101110 base 2 is equals to 16A base 16. Okay, now the conversions from binary to octal is done, from octal and hexa is also done, right? Now we will convert it back. Okay, octal to binary, okay, that means base 8 to base 2. How you will do? So for suppose if I have a number called 174 base 8, if I wanted to convert it into binary, then how you will write is, you write 174 in 3 bits. 1 is represented as 001, 7 is represented as 111, 4 is represented as 100. So this is my answer in binary. Okay, similarly, if I wanted to convert, let us say 1AC base 16 to base 2. Okay, what you will do is, you will be representing each and every number in 4 bits. 1 is represented as 0001, A is represented as 1010, and C is represented as 1100. Okay, so this is my answer in binary, right? So now I have seen all the conversions, right? So I have seen from binary to octal, binary to hexa, and octal to binary also is completed, hexa to binary is also completed, right? Now we will see with the octal what is left. Octal to decimal is, octal to binary is completed, octal to decimal is completed, octal to hexa, and hexa to octal is a 2-step process. Okay, what we do is, for suppose if I wanted to convert 174 base 8 to base 16, okay, that means octal to hexa. This is a 2-step process. What you will do is, there will be one step called as, like 174 base 8 is first converted into binary, then you convert your number to base 16. Okay, so how you will represent 174 in binary is nothing but 1 is represented as 001, 7 is represented as 111, and 4 is represented as 100, right? So this is in binary. Now this is octal to binary, 3 bits represented. Now you convert this binary to hexa. How you will do? 1 2 3 4, you divide it in 4 bits. 0 111 0, so this is 0, 7, and 1100 is C. Okay, so this is the answer. 174 base 8 is nothing but 07C base 16. Okay, similarly, if I wanted to convert a number from hexa to octal, right? So if I have a number called as, let us say 1AD base 16 to base 8 I wanted to convert. Again, this number system is having a two-step process. First you convert it to binary, then you convert it to octal. Okay, how 1AD is represented? 1 is represented by 0001, A is represented by 1010, D is 1101. Correct. So now you represent each and every bit in 3 bits. So this is 3 bits, 3 this thing. So this is 0, 110 is 6, 101 is 5, 101 is 5. Okay, therefore 1AD base 16 is equals to 0655 base 8. Okay, so this is how you convert all the number systems. I hope I have covered all the number systems, right? So all the number conversions. Okay, hexa to binary we have seen, hexa to octal we have seen, hexa to decimal also we have already seen. Okay, now for suppose in any number system, if there are fractions, okay, fractional numbers, how you will deal is, for suppose you see, if I have 23.46 base 10, if I wanted to convert it into binary, then what you will do is you do it in 2 parts. Okay, this 23 you divide it by 2. Okay, so this 23 if you divide it by 2, 2 11s are 22, the remainder is 1, 2 5s are 10, remainder is 1, 2 2s are 4, remainder is 1, 2 1s are 2, remainder is 0. Okay, you write it here, you write in the reverse order, right? 10111 point. Now this decimal fraction has to be 0.46. You write it separately and you multiply by 2. Okay, if you wanted to convert it into binary, you multiply by 2. If you wanted to convert it into octal, then you multiply by 8. Okay, and the procedure remains same. Okay, even if you wanted to convert it into hexa, you multiply by 16. Okay, you see here this 0.46 into 2, 2 6 are 12, 2 4 are 8, this is 9, 0 point. So whatever weight comes here, you will drag it to here. Okay, now you again multiply by 2. Right, now 2 2s are 4, 9 2s are 18, and this is 1. So this is 1.84. Now this is 1 point, this 1 will be coming here. Okay, and you multiply your 0.84 again. Okay, you remove this 1 and you multiply 0.84 into 2. 2 4s are 8, this is 16, so this is 1.68. Again this 1 is written here. Okay, again you take your 0.68, you multiply by 2. Okay, so this will be again this is 16, 13, this is 1.36, so you draw it here. So this will be your answer. Up to 4 bits or 5 bits is more than enough. Okay, in the fractions you can take this as the fractional answer. So the procedure is same. Okay, if you have a fractional number in decimal, you can convert it into binary by multiplying the fractional part by 2, and into octal by multiplying the fraction part by 8, and by to hexa you multiply the fractional part by 16. Okay, this real part is same, just division only. Okay, now for suppose if I wanted to convert in the reverse. Okay, let us say I have a number called as 147.23 base 8. If I wanted to convert back to decimal, okay, it's a fractional octal number. I wanted to convert it into this one, right? So how you will convert? We have already seen. I need to multiply by its weight. This is 8 power 0, 147.23, right? This is 8 power 1. This is 8 square. So here it will be 8 power minus 1. Here it will be 8 power minus 2. So this will be 8 square into 1 plus 8 power 1 into 4 plus 8 power 0 into 7 point 8 power minus 1 into 2 plus 8 power minus 2 into 3. The answer will be this one. Okay, so this is 64 plus 32 plus 7 point 2 by 8 plus 3 by 64. So you get whatever the answer you get here. So this will be, so whatever the answer, you can calculate this one and you can put it the answer back. Okay, so this is how you convert a fractional number in any number system to decimal. Okay, so I hope you have understood the number systems to convert from one number system to other number system. So if you understood the concept, then please like the video, share it to your friends and subscribe the channel. Thank you for watching.